Let me know if you've done this before so I can change the question.
Given the root of the binary tree, return the sum of the values of the nodes with an even valued grandparent. If there are no values with an even valued grandparent, return zero. I don't think so. I have solved this before.
Yeah, so that is your question.
Let's just write it down, guys. Let's say I have six, uh, maybe five, maybe three, mm, one here, two, um, four, and eight. Okay.
Hmm.
So the question says, given the root of the binary tree, return the sum of values of nodes with even valued grandparent. If
Hmm.
there is no value, return zero. So if this is my current node, its current grandparent would be this one, six, right?
Hmm.
And six is even. So I mean six is even. So I can add two to my sum. I can add one to my sum, and I guess there won't be anyone. So if this five instead of five, let's say we had an eight. So okay, so I mean in the sum I could have this one, this two, this four, and this six, right? So my output will be two plus one is three, and this is 12, so 15, right? Yeah, 15 should be my output, right? For
Hmm.
this particular example. Okay. Mm, just give me a minute. We can just make a simple DFS call wherein
Okay.
we will be passing a current node,
Hmm.
and while passing it, we can pass its parent or even grandparent. I guess we have to pass both parent and grandparent, and we will be doing it an DFS call. We will be updating parents and grandparents at each layer,
Okay.
and if the current one, if for current one the grandparent is even, then we will be including it in our count.
Okay.
So yeah, I guess that will do the trick.
Sure.
So let's say I am I have can I write the code directly, because I mean
Yeah, yeah,
uh,
sure, sure. That
okay.
makes sense as well.
So int I have to return the sum equals to zero, and then I will be having a DFS call
Hmm.
which will be taking my current node, its parent, uh, let's say parent, and its grandparent. Okay. So initially for the root node, parent and grandparent will be null. So let's just say now, I mean, if my current is null, I have to return. I will be returning the call. Now, uh, percentile two equal to zero. Sorry, let me read the question. Sum of the values of node if even value, the grandparent is even value. Okay, so I'll just say if grandparent is not equal to null, and grandparent dot val percent equal to zero. So my grandparent exists and he has even value. So at that point, my sum, which is a global variable, plus equals current dot val. So that will be updated. And now I will be making DFS calls. So I'll just say DFS current dot left, uh, parent, sorry, I'll be passing current as my parent, and I will be passing my parent as the grandparent of my successor.
Okay.
uh, and then I'll be making another call for the right subtree, current comma parent. And yeah, in the end I will be having the value that I'm looking for. By the way, while making the call, I'll just make it like this.
Just a
Uh,
minute. I need to check something as well. Uh, just 1 minute. Let me think of a corner case for this. Hmm. Okay, makes sense.
okay, so the time complexity will be of order n because I will be traveling the entire tree once,
Hmm.
where n is number of nodes, and my space complexity will be of order 1. I'm making a recursive call, so the recursive stack will be there, but I don't think so. It will be counted as in the space complexity. Uh, yeah, so this will be the final solution.
Check. Makes sense. Looks good to me. We can do one more question if
Yeah,
you want,
yeah,
right? That
yeah,
makes because
definitely.
it's going good because yeah, that will only be good for us if we do that.
Yeah.
Just 1 minute. Acha, so this is not programming. It's a programming question per se as well, but we'll just discuss the approach of this question, right?
Okay. Yep.
Um, and I don't think questions like this can be asked or not, but it's kind of puzzle kind of question. So
Yeah.
at the end, the
Okay.
interview might be looking for something like that or not. So if you want that, or do you
Yeah.
want a proper programming question?
I guess the first one sounds good. I'll be exploring something new. So yeah,
Okay,
we can
sure.
go with the
Okay,
puzzle.
yeah, we can try something new. Given two players A and B and a list of numbers in sorted order. So the list can be something like, okay. So there are two players, right? Let's say you are A. So A is Prajwal and B is Dikshit. So we are playing a game where we have a list of sorted numbers, right?
Yeah.
And yours is the first move. In one move, what you can do is you can select any number. Let's say
Okay.
you select 3. So all numbers below 3 will be eliminated from the list and one frequency of 3 will be deleted. Meaning that
Okay.
if the list is 112, 11222 and 334. So if this is the list and if you select 3, then the eventually the list will be just this because one frequency of 3
Yes.
will be deleted and all numbers below 3 will be deleted.
Yeah.
So now it's my turn, right? What I can do is I can select 4. So the list becomes empty. You don't have anything to move on to play basically, right? So
Yeah.
I win this game.
Okay.
So we have to play in such a way that the other person is left with no moves to make.
Okay. Yeah. Makes sense. So let me just take it to the editor. So when a player chooses a number, all the numbers below it and one of its frequency gets one number from its words get reduced, and I have to do it. So then the next player will play. The process will be repeated until one of them has the empty list, and whichever one has the empty list, that person will lose the game.
Hmm.
Okay.
The person that cannot play a move, that is the loser basically.
Yeah.
Hmm. And we'll
So
have a list, so it's not like कि input nahi hoga. That constraints are all out of the game.
yeah. Yeah, so let's just consider the last case first. When I mean I have the empty case, empty
Hmm.
array. What will be my second last step, the step that A has played, which has resulted into you know um, the game to be over. Uh, could it be one? I don't think so, because every time I'm limiting the numbers which are lesser than one. So the numbers 2, 3, and 4 are still there. I mean,
Okay.
the frequency of 2, frequency of 3, frequency of 4 is still there. So I don't think so. 1 is the right one, the last number that I'll be left with. And it won't be 2 and 3 there. It will be 4, the largest number,
Hmm.
right? Because that's the only thing that will make sense. I will be having 1, 4. Uh, I mean, I might have other numbers as well here, 1, 2, 3, 1, 2, 3, 3, 3, or something like that. As long as I have only one frequency of 4, everything before that really doesn't count. Does
Okay.
that make sense? Uh, right? I mean, right. If this is the case,
Hmm.
I have unknown number of other numbers and
Hmm.
only one frequency of the largest number. Then I can
Okay.
just get this one, and the other person will have nothing left in his plate. So somehow I have to produce this step. Let's say this is player A, this is player B. So if player A chooses 4, the B will lose. So that's the first observation. Um, okay,
Even I forgot the approach for this. Let me think on this as well.
yeah.
Um,
I mean, if both of them are following this particular, okay. Uh, if A wants to win. Okay, so let's just say this is the case.
hmm.
Now, whichever one has this particular output, he's gonna win. That's for sure. You
Hmm.
can't deny that fact. Now, let's say I have another 4. So, if I'm choosing 4 this time, the largest
Hmm.
number,
Hmm.
then the next case will be 4. The remaining part will be 4, and the other person can pick 4, and I'm gonna lose the game. Right? I mean, here there are two possibilities. First possibility is pick 4, 4, and you will lose. Right? After this one, after this particular array, I have to choose one number. If I am picking 4, the largest number, I'm gonna lose the game.
Hmm.
If I'm picking the number uh, less than 4, will it matter? I mean, let's say I'm choosing 1, so I will still be having a lot of numbers to deal with. If I'm choosing 3, uh, if I'm choosing 3, I'll be left with this. Mm, and it doesn't matter. So let's just create a rule book. Okay. If you want to play, you have to follow the rules. If you want to win, you have to follow the rules. First rule one is if frequency of max element equal to 1, pick it and you will win. Okay.
Hmm.
And rule 2 could be if frequency of max equal to 2. So there are two elements. At that time, if you pick, so there are two possibilities. First possibility is pick pick max element, which will result in you losing the game, right? The other possibility will be picking a number which is less than uh, let me think. If the number is less than this one, I will be left with either 4 4 or 3 4 4. Yeah, pick element, pick less than uh, pick a number which is less than max, and it will continue the game. uh, so there could be two different possibilities after this, like 4 4, or other possibility could be 4 or 4. So in any ways, I'll be going to this step itself. Yeah, I guess, I mean, I'm not really sure if the person will win or lose if he chooses the number which is less than max, but the game will be continued for sure. um, can I make another rule set of rules for this? um, let's say my frequency is another 4.
Okay.
So if I'm picking this one, uh, the other person will be left with set of fours, that is the repetitive number.
Hmm.
What will happen after that? Actually, after one step, the process will be reduced. Let's say even if I have this particular step, right, this particular array. So initially I will be choosing the largest element.
Hmm.
I'll be left with only fours, and now it's just a matter of even and odd length of the remaining ones. I mean, after I mean, let's say I had 3 4, something like this, the numbers which are less than 3, and then I had 4. Now I'll be choosing this, it will be eliminated, and numbers after that, B will choose, A will choose, B. Okay, so if the remaining ones are odd, then B will win. Okay, let me just form it properly. Let's say this is my array, right?
Hmm.
So now I have chosen this 4, the maximum element, and all of them have been reduced, right? So now there's only one option, or one person has to pick one number. And at this time, if there are odd, I mean, after the first step, after choosing the maximum one, choosing max number.
Okay, let me give you the simple approach, and then we can move to discussing OS related questions.
Okay, yeah,
So you can, okay, so there is a pattern in this. If any number has a frequency that is odd, right,
okay.
then you'll always win.
I just have to choose the number which has odd length.
No, no. If any number in this entire list is odd, has a odd frequency, then you'll
Okay,
always win the game.
any number in the, okay, so it really doesn't matter. So
So you can write any list, and let us basically consult our hypothesis.
this one.
So what you are, let's say I am player one and you are player two.